Hi, my name is Yuvaraj Analatipinalan with matrix number 196320. So today I want to do my project fluid mechanics. So first, liquid characteristic. So there are a lot of liquid characteristics. First is definite volume but indefinite shape. When a liquid is inside a container, it will take its shape. Second, able to flow and take any shape. This occurs due to the weak intermolecular bonding that allows the molecule to slide past each other freely. Third is undergo diffusion when mixed. Diffusion will occur faster when the liquid is warmer because the increased kinetic energy allows the molecule to move faster and collide more frequently. Third is considered incompressible. The molecules are already close together, so it is difficult to compress them anymore. And the last one is have a distinct surface. They need not take their container shape. This allows the formation of droplets and puddles. There are some special characteristics for water. First is density. The density are more precisely the volumetric mass density of a substance is mass per unit volume. The symbol most often used for density is ρ. The density is defined as mass divided by volume, where ρ is density, m is mass, and v is the volume. ρ is equals to m over v. Viscosity. Viscosity refers to the liquid resistance to flow. A solution with low attractive forces will allow the molecule to move in a more free and easy manner, decreasing the viscosity. The viscosity of a liquid decreases as the temperature of a liquid is increased. Increasing the temperature of liquid causes the molecules to have a higher kinetic energy. This increase in kinetic energy breaks down the intermolecular forces present in the liquid. Next, specific weight. The specific weight is the weight per unit volume of a material. The symbol for specific weight is gamma. Gamma is equals to rho g, where gamma is equals to specific weight of the material, rho is equals to density of the material, and g is equals to acceleration due to gravity. Next is specific gravity. Specific gravity is the ratio of the density of a substance to the density of a reference substance equivalently. It is the ratio of the mass of a substance to the mass of a reference substance for some given volume. Apparent specific gravity is the ratio of the weight of a volume of a substance to the weight of an equal volume of the reference substance. The reference substance for liquid is nearly always water at its dense 4 at which is at 4 degrees Celsius or 39.2 Fahrenheit. Specific gravity is equal to density of the object over density of the water. This is the formula of specific gravity. Next is temperature. It is the property that determines the degree of hotness or coolness or the level of heat intensity of a fluid. Temperature is measured by using temperature scale. There are three common used temperature scale: degree Celsius, Fahrenheit scale, Kelvin scale. Next is pressure. Liquid will distribute pressure evenly. This concept known as Pascal law. It is crucial for equipment like hydraulic brakes. Next, the evaporation increase with temperature. It can measure by vapor pressure, the amount of pressure exerted by the evaporated gas above the liquid surface. Vapor pressure increase with temperature, and once it reaches the pressure of the surrounding atmosphere, the liquid will be boiled. Vapor pressure also depends on the intensity of the molecule force in the liquid. Next is specific volume. Specific volume of a substance is the ratio of the substance volume to its mass, the reciprocal of the density, at an intrinsic property of matter as well. Specific volume is defined as the number of cubic meters occupied by 1 kilogram of a particular substance. The standard unit is cubic meter per kilogram. So this will be the formula, the main formula for specific volume, which is m is equals to rho v. V is equals to V dot over V is equals to rho AV dot. So this will be the main formula. Next is surface tension. When water droplets on an impermeable surface, they tend to form beads. This is due to surface tension. Liquid molecules will pull each other, and as a result, they decrease their surface area. The molecules at the boundary of the liquid are pulled, it's causing a droplet shape. So this is all the characteristics of the water. Next, we're going to enter dimension analysis. Dimension analysis is the mathematical technique used to predict physical parameters that influence the flow in fluid mechanics, heat transfer in thermodynamics, and so forth. The analysis involved the fundamental units of dimension is MLT, which is mass, length, and time. It is helpful in experimental work because it provides a guide to factors that significantly affect the study's phenomena. Dimension analysis is commonly used to determine the relationship between several variables, example, to find the force as a function of other variables when their exact function relationship is unknown. So uh, this will be the question. So first, the question is, the resistance force R of a supersonic plane during flight can be taken as the functions of length of aircraft, velocity, air density, and bulk modulus of air. Express a functional relationship between this variable, which is L, V, mu, rho, and K. So first step is Rayleigh method. So first we're going to write like R directly proportional to length power of A, V power of B, mu power of C, P power of D, and K power of E. So it is become R is equals to A, L power of A, V power of B, mu power of C, rho power of D, and K power of E. So then we substitute it with their own units, which is MLT negative 2 for R, A, L power of A, and for V, LT negative 1 power of B, and for V, ML negative 1, T negative 1 power of C, and for rho, ML negative 3A, and for K, ML negative 3, T negative 2 power of E. Then we are going to arrange it according to A, M power of C plus D plus E, L power of A plus B minus C minus 3D minus E, T power of minus B minus C minus 2E. Then there are 5 unknown, which is A, B, C, D, and E. So we're going to do simultaneous equation for this part, which is C plus D plus E is equals to 1, A plus B minus C is equals to 3D minus 1 equals to 1, and B plus C plus 2E is equals to 2. So this will be our main 3 simultaneous equation. Then we're going to solve it, the simultaneous process, and finally we will get R is equals to A power of L, R equals to A L power of 2 minus 3C, V power of 2 minus C minus 2E, mu power of C, rho power of 1 minus C minus E, and K power of negative D. And then we sub the thing, and we finally will get R is equals to A power of A rho V power of 2 L power of 2 mu over L squared V rho power of C, and K over P V squared power of D. So this will be the final equation for us, R in terms of the 5 variables. So next is Buckingham's theorem. We're going to use the same question to solve it. So Buckingham's theorem, there are 3 main things, which is n is equals to total variable, m is equals to fundamental variable, n minus m is equals to dimensional variable. The dimensional variable will be the pi term. So for getting the pi term, we need to have the repeating variable. So there are the variables are R, L, V, rho, mu, and K. So first, we're going to write R is equals to F bracket L, V, U, P, and K. Then we're going to write F is equals to R, L, V, mu, rho, K is equals to 0. So for the n is equals to 6. There are 6 variables, total variable, and m is equals to 3, the fundamental variable, and n minus m is equals to 3. So for getting the pi term, we need to have the repeating variable. So to choose the repeating variable, there are 3 main factors, which is geometric property, flow property, and fluid property. So which is L, V, and rho. So using the repeating variable L, V, and rho. So first we're going to write at pi 1, pi 2, pi 3. Pi 1 is equals to L power of A, V power of B, rho power of C, and R, pi 2, and pi 3. So we're going to write next is F power of F, pi 1, pi 2, pi 3 is equals to 0. So this will be the dimension, which is the unit for all the variables. So we're going to solve it with writing all these things in equation for pi 1, pi 2, and pi 3. So during that, we're going to find that the C1, C2, C3 variable, and then for the pi 1, we will get L power of negative 2, V power of negative 2, P power of negative 1, R. So this will be the final pi 1. So for the pi, the same things goes for M 2, and this will be the final pi 2. And for the third pi 3, it will be this part. And then we're going to write F1 equals to R over rho V squared L squared mu over L Vp and K over V squared rho equals 0. So we substitute back, then we will get R over rho V squared L squared is equals to pi bracket mu over L Vp Kv squared P. So this will be the final equation for our Buckingham's theorem. So that's all from me today. Thank you.